Hello and welcome back to AP Human Geography. Today we want to talk about folk medicine. And the real question is that we want to start with is what is folk medicine? It's a healing kind of tradition that is inherent to a culture or society. It uses natural supplies. It really reflects the geography of the area because obviously it's centered highly around plants that are available. And of course, a lot of times you're going to have a religious component to it, which again is based on geography. And here you're actually looking at a Mexican healer. And we can generally divide folk medicine into two subjects, if you will, and that's folk diseases and folk remedies. And we're not going to spend a lot of time on folk diseases, but essentially the things that were considered ailments throughout history can generally fall into four categories. You have the actual diseases or injuries or whatever, things that are, real, scientifically unchallenged. But then you have three other things. You've got mystical causes, and those are things related to destiny or karma or, lost souls or whatever. And then you've got supernatural causes, and those are going to be based on gods, angry ancestors, spirits, ghosts, whatever. Usually it's vengeful. And then you have magical causes, which of course go back to the idea of sorcery and witchcraft. And of course, if it's a disease, obviously it's harmful. Now, we see a lot of these herbal remedies today, these folk remedies, in things that we do. And a lot of times it starts with, my grandma used to, right? And so if you think about just the common cold, there's a million things that people do. Obviously drink lots of fluids, which is true. Eat chicken soup because that makes you feel better, maybe, right? Drink mint tea, drink echinacea tea, gargle with salt water. And actually gargling with salt water does seem to have a sort of helpful thing for many people with sore throats, but it may or may not actually be that. Eat lots of oranges for the vitamin C. You can only process so much vitamin C, so there's that. And then of course there's the big lather up with Vicks and bundle up, right, for your congestion. These are not actually based on anything scientific. Now, there may be science that would support them, maybe not, right? But these are all just things that people do because they think it makes them feel better. And so these are folk remedies, right? And folk remedies can include prayer, herbs, foods, and lifestyle changes. And many of those things actually go into real medical remedies, real medicines. So which of the following would not be considered a folk remedy? Wearing an evil eye pendant to ward off spirits, cleaning a wound with vinegar, eating almonds for heart health, or removing illness with a raw egg. Now obviously two of these are not things that the modern person would do, wearing an evil eye pendant to ward off evil spirits and removing illnesses with raw eggs. That is actually something that healers do, and there is con artistry that goes with that. And if you're interested in that, you can ask me in class. But cleaning a wound with vinegar and eating almonds for heart health, those are folk remedies, but they do actually have benefits, right? I mean, vinegar is acetic acid, and so it does help clean wounds. It helps kill bacteria and things like that. And eating almonds for heart health, they have good fats in them. But all of these would actually be considered folk remedies because they're just kind of things that you do, unless, of course, it's something that is medically accepted. Okay, so all of these are folk remedies, even if they work, right? So what's the history of folk medicine? We may not actually have been the only humans to practice folk medicine. We have very little evidence that anyone else used plants medicinally. Having said that, though, there was a grave of a Neanderthal man that was buried about 60,000 years ago, and the pollen analysis indicates that the plants that were buried with the corpse were of medicinal value. Now, that doesn't mean that the Neanderthals knew that they were of medicinal value, but maybe they did, right? So we don't have any solid anything solid at all, actually, on that, but still. Now, we do know that we have been actively using herbal remedies for probably around well, at least 4,500 years. And here's just a list of several things that you can see that people actually thought this was important enough to record, right? All of these works have herbal remedies or are the basis of herbal remedies that come later, right? But we really hit the peak when we have the ancient Greek and Romans who are really recording knowledge, and the basis of Western medicine actually comes from the work that they did. Hippocrates, who's the father of medicine, and Aristotle all compiled lists that and/or administered herbal remedies, and then you have Dioscorides in the 1st century who actually wrote De Materia Medica, and that has over 600 species of plants that have medicinal values. And many of these are actually still in use, including willow bark tea, which we'll talk about later on. But this was the standard medical reference for for 1,500 years. So these things, many of them seem to work, right? And we'll talk about that in just a bit, okay? Now, the beginning of the Renaissance in the early 15th century, this is where you start to have this renewal of learning. We go through the Dark Ages. Nothing much exciting happens in the way of knowledge in the Dark Ages. But then we get this revival of herbalism for medicinal plants. And the great thing about this is in 1440, the printing press allows this knowledge to be shared. Now, granted, it's with anyone who can read, but still, you can record and share all of this knowledge. And then we move into the Age of Reason. And in the 17 and then 1800s, modern medicine starts to appear, and scientific botany splits from traditional herbal remedies. And we do find out at this point that many herbal remedies do have a sound scientific basis. Foxglove, for instance, is one we'll talk about in a minute, actually does treat congestive heart failure. And the study that showed that set the standard for pharmaceutical chemistry in the years to follow. And so scientists actually began pulling out, purifying the extracts from the plants that were the medicinal components. And this really sort of crystallized with, well, I didn't mean that actually, but it works too, with the morphine isolation from the opium poppy in the early 1800s. And then people started to develop synthetic drugs, and direct use of plant extracts decreased because we learned that we could synthesize these things. So here is your question. Some folk remedies are based on the same properties that make certain plants desirable in the drug trade. Well, you can see the pictures here, and that is true. What you are looking at on the left is an Afghani opium field, right? Afghanistan produces lots and lots of opium and heroin, right, from the opium poppies. And then on the right, what you're looking at is the coca plant, which would be the source of cocaine, okay? And so we'll talk about these two things later on, but obviously, in small doses and administered properly, some of these things can be helpful, right? They can be medicines. Otherwise, they are drugs, right? So, herbal medicine today, somewhere between 75 and 90% of the rural population in developing nations still use herbal medicine. And in some cases, it's their only health care because there are no doctors, there are no clinics accessible, and so that's what they have. In many places, medicinal herbs are actually sold alongside of other foods in village markets. But as you can see from this picture here, there are modern herbal stores, right? And so people who have access to healthcare also are continuing to use herbal medicine. Typically, practitioners of herbal medicine do undergo an apprenticeship or some sort of training so they can learn the plants and their uses and how to prepare them, because you can really kill people with these sorts of things. You can hurt people. They can be really toxic, and we'll talk about that in just a minute. So, herbal remedies are old wives' tales. Well, we like to think, oh, if you're having like a folk remedy, it's a, quote, old wives' tale, something that doesn't really... An old wives' tale implies that something isn't true. But again, there are herbal remedies that do work. And the question is, which ones of those are valid and which aren't? So herbal remedies, all herbal remedies being old wives' tales is false. Okay, so here are some common herbal remedies that you may actually have seen or taken yourself. Echinacea is supposed to boost the immune system. St. John's wort is an antidepressant. Ginkgo is used for increasing capillary flow, and a lot of people think that it increases your memory. Chamomile is for relaxation, and then people take ginseng for all kinds of stuff. I mean, there's a whole laundry list of stuff that people take ginseng for, and it's considered like a wonder herb. So the real question is there any scientific basis behind this? But here's my first question. Herbal medicines and supplements are regulated by the FDA. That is false. They are not regulated by the FDA. Okay. So there you go. When you get an herbal medicine or supplement that you purchase, there is no one really that is verifying that that's true. No central facility, centrally organized group that makes sure that you're getting what you actually think you're getting. Okay. Now, moving on from that, this is really dangerous because the things that we're looking at, these are active components of plants. All of the things that we use for our herbal, right, our medicinal plant stuff, come from secondary metabolites, and secondary metabolites are things that are produced by the plants that don't have a direct use out of like photosynthesis and for metabolism, things like that. And so I've put over here, and you don't have to know this, but I've put in a little flow chart of where the big things come from. Our big three, which are our nitrogen-containing compounds, our phenolic compounds, and then the terpenes. And we're going to talk about some of those. I would like to point out that plants make lots and lots and lots of secondary metabolites for all kinds of things. We are going to be focusing on the ones that have medicinal value, okay? And like I said, the major categories were the terpenes, the nitrogen-containing compounds, and the phenolic compounds. Again, there are lots and lots more of these things. We're just focusing on the medicinal things, right? So why do plants produce these secondary metabolites? Well, it depends on the type of metabolite, but we're going to start with terpenes because they are in fact the largest class of secondary metabolites, and their functions range from defense, essential oils, plant growth regulating hormones and plant steroids, photosynthetic pigments like the carotenoids, and they also are used to anchor molecules into cell membranes and cell walls, right? So there's a lot of different things going on here. The terpenes that we're most interested in are the cardenolides and the saponins, right? And cardenolides actually affect heart muscle contraction. They are deterrents to herbivory, right? In really low dosages, this is what we're talking about, they can treat dropsy or heart failure, right? The plant over here, this is it. It's a foxglove. It's in the genus Digitalis, and it produces digoxin and digitoxin. In larger doses, it is absolutely lethal. And this is the kind of plant that you have to be careful having in your garden, because if kids or animals or something, or random people, eat it, it can kill them. It's also found in milkweed and oleander, right? And again, both of those are absolutely lethal, okay? Saponins are a different type of terpene. They are highly toxic, and they can cause severe gastric irritation as well as hemolytic anemia. And interestingly, though, one of those is disogenin, which comes from yams, but it can actually be used to synthesize other hormones, including progesterone and cortisone, right? Both of which are very useful, okay? Now, moving on to the alkaloids, these are another really diverse group of compounds. There's over 3,000 that have been identified. We're going to talk about just a couple, but there are three major alkaloid-producing families, and that's the legume family, the nightshade family, and the coffee family, okay? Now, these are things that are going to really affect the nervous system most, okay? They can also have psychological effects, and some common alkaloids that you probably know are caffeine, nicotine, cocaine, morphine, quinine, ephedrine, codeine, strychnine, and capsaicin. And so, and again, we'll talk about some of these in just a second. All right, here's your next question. Actually, we're not. Sorry, I'm going to go back to that. Okay, so caffeine, that's in coffee, right? Nicotine, that's what's in cigarettes. Cocaine, I'm sure you know what that is. Morphine is a painkiller that's derivative of the opium poppy. Quinine is a malaria treatment. Ephedrine is an it's a decongestant. Codeine, pain reliever. Strychnine is a poison. Okay, it's what's in certain types of rat poison. And then capsaicin is the stuff that makes your mouth burn when you eat hot peppers. Okay, so your next question is this: which of the following is not a member of the nightshade family? Now, as you're thinking about this, I want to point out that the nightshade family, these are lethal. This includes, nightshade is absolutely lethal. Black nightshade grows here in the United States. Belladonna is another poison that is in the nightshade family. It was used by Egyptian women. They'd put it in their eyes and it would make them sparkle because it made the pupils dilate, and so that was considered attractive. So they would look glassy and with huge pupils. Over time, it can actually cause blindness. But anyway, so which of the following of these things that you know and maybe love are not in the nightshade, which means everything else is? Tomatoes, yep. Bell peppers, yep. Eggplants, yep. Potatoes, which I apparently cannot spell. I'm gonna fix that really fast. Okay, I'm back. Potatoes, those are all in the nightshade family. Cucumbers are not, right? But everything else is in the nightshade family. And think about bell peppers, they're related to jalapenos and cayenne peppers, ghost peppers, all of those things. That's that capsaicin, okay? Now, the next group we want to talk about, these are still alkaloids, just like alkaloids, yep. Oh, sorry, they're nitrogen-containing compounds. So the cyanogenic glycosides, nitrogen-containing compounds, they actually release cyanide when they break down. They are extremely toxic. The only one that we're going to talk about is amygdalin, because the rest of them don't really do anything helpful for you. These are found in the seeds and pits of many things that you're familiar with. These are actually part of the rose family that makes this amygdalin. Apple seeds, pear seeds, almonds to a little bit, apricot pits, cherry pits, peach pits, and plum pits, right? You can see this part actually does have amygdalin in it in varying amounts. It is highly toxic. It is so toxic it is actually banned in the United States. There's been a renewed interest in it as a cancer treatment, although most studies are not really showing that it's giving good results, although people are still trying to figure out what's going on with that. So anyway. All right, so the last one we want to talk about are the phenolic compounds. And this is a really diverse group. There's over 10,000 compounds in this that we've identified, right? And the functions include defense against pathogens, defense against herbivory. And by the way, isoflavonoids and you'll see those in vitamins. They're like, and isoflavonoids. Those are actually defensive molecules for plants. Tannins that you find in red wine, it's the thing that gives most people headaches if they're going to get a headache when they drink it. That's a defense against herbivory, right? Lignin is for mechanical support. It actually helps build the woody structure of stuff. And then they're used for attracting pollinators. Those are the anthocyanins. They come in red, pink, and purple, and you can see all of these guys are colored this way because of anthocyanins. You can also have some phenolics that are for UV absorption that protect the DNA of the plants, and those are your flavonols and flavones too, actually. And then these are guys that can inhibit growth of neighboring plants, right? Now we're going to focus on two of them. Coumarin, which is an anticoagulant. It's used in two places. It's used in warfarin, which is a pesticide. It kills rats by causing them to essentially internally bleed to death. But it's also in Coumadin, which is a blood-thinning medication that saves people's lives. And this goes back to the idea that the dose makes the poison, right? It depends on how much you get as to whether it's going to be helpful or lethal. And this is why you don't mess around with these things, that you actually learn what you're doing and are very careful. The other one that we want to talk about is salicylin is a protein that's produced by willow bark, right? And from that you can get salicylic acid, which is aspirin. It's an anti-inflammatory agent and a fever reducer. We do this synthetically now, but this is actually willow bark right here. This is it ground up, and then of course that's aspirin. Some other important medicinal plants right now include, or not necessarily specifically right now, but have some other important medicinal plants that we have used include fever bark tree. That's where we get the quinine, which is the malaria treatment. Snake root gives us a protein that's really good for hypertension or high blood pressure, which is called reserpine. Aloe, there's a bunch of glycosides in that help burns. Vinca produces vincristine, which is a leukemia treatment. The Pacific Yew is actually really exciting right now. It produces Taxol, which has been shown to be successful in treating ovarian and breast cancers, right, which is great. And then there's the autumn crocus, and I put the autumn crocus in here not, I mean, colchicine is an important, right, protein that we use. It treats gout, and it's also used in treating IBS in women because it's an anti-inflammatory, which is why it helps gout. But the autumn crocus is, I think, interesting in here because you've probably seen the autumn crocus before. It's one of the really common examples of reproductive isolation in plants and speciation, because there's a spring crocus and there's an autumn crocus, and the reason they don't interbreed is because of timing, right? Obviously with the spring and the autumn part there. But fun fact about them is that they are actually medicinal. So I thought that'd be fun. All right, so where are we today? Today, medicinal plants really do contribute significantly to our prescription drugs, and I don't think we realize it. 25% of all prescriptions written in the United States contain plant-derived active ingredients. Okay, 50% of fungal products are included. And there's an even larger percent based on semi-synthetic or actually wholly synthetic ingredients. So you may actually be taking something that's not considered a plant-derived medication because it's synthesized, but that original compound or molecule comes from a plant, right? So there you go. And there's been a huge resurgence in interest in plants for medically useful compounds, because we've started to really understand disease better, and we've started to understand how plants work better, and we have really good ways of testing to see if things work. And so plant-based treatments are becoming really much more in the forefront of research, especially in terms of cancer treatment and things like that. So that is it for this this lecture. If you have any questions, you can either put them on the Google Doc, the question board, or you can ask them at the beginning of class. Thanks for listening, and I'll see you next time.